Hi, my name is Chet Davis, and this is an introductory video on how easy it is to use EasyPower for creating one-line diagrams, automated design, short circuit, protective device coordination, and arc flash hazard analysis. We're going to start off creating a one-line diagram with simple mouse clicks. I'm going to left mouse click on this utility, left mouse click again in the drawing area. You can see it snaps to grid. I'm going to grab a conductor. We'll left mouse click, drag and release, and we'll say that this is a 13.8 kV conductor in this wizard, and then it snaps in a connection point or a bus. And what we'll do now is grab a transformer, two-winding transformer, left mouse click, snaps in the high voltage bushing terminals of the transformer, and then on the secondary side we'll put the low voltage busway, and we'll make that 480 volts. Say OK. That snaps in the secondary low voltage bushing terminals, the busway into the switchgear lineup. So we'll grab a low voltage switchgear lineup, and we'll make that with a main 480 volts, low voltage power circuit breakers. We'll say 3 motor control centers connected with conductors down to MCCs, and that creates that for us. And then we'll just left mouse click, snap that together, and there in 6 or 7 mouse clicks is a typical unit substation that you would find in any industrial or commercial type facility. What we want to do now is add some load to the motor control centers, and then what we'll do is we'll have Smart Design completely automate the design process by sizing all the equipment per NEC code requirements. So I'm going to left mouse double click on this motor control center. I'm going to go to the description tab, tell it that I have 2 buckets, and you can have as many buckets as you choose, but in order for this demo we're just going to keep it small. I'm going to make the first group less than 50 horsepower motor group, and then we'll have a motor with a time current curve. Now I'm going to click on this motor spec tab. I'm going to slide the cells over, and I'm going to put, say, 150 horsepower of group motor, low voltage motors, and then I'm going to click on this data button for the larger specific motor with the time current curve, and I'm going to say this is a 200 horsepower unit, 240 full load amps, short circuit ANSI code greater than 50, X over R ratio of 12, and then I'm going to slide over to the protective device starter information, and I'm going to size the conductors and the breakers for this 200 horsepower motor. So I'm going to right mouse click, auto size, tells me the row was successfully sized with a mag brake, GE mag brake TJC 400 amp, interrupting 30 kiloamps, and now we're good to go. Also notice if we slide this over, you can see that the conductor was sized, the conduit run, and that type of thing. So what we'll do now is just select OK. Now what I'm going to do is, in the essence of speed, I'm just going to copy this to the other MCCs. So I'm going to right mouse click, copy, left mouse click, press slide release, right mouse click, paste, and now that information is in the other motor control centers. Now that we have the MCC's load documented, what I'm going to do is come up and grab a high voltage breaker for this feed. And there's some other features that we have. Let's go to Insert, Subsystem. I'm going to grab a Basler 851 relay system, and I'm going to highlight that and just drag it over and snap it in. And so there's the 851 relay system. Now we're ready to size our equipment, so what we'll do is we'll just highlight this, right mouse click, and we'll go auto design, and you can see that our equipment, all our conductors and our transformer are all sized. And now we're ready to go analyze the power system. First thing we want to do when we analyze the power system is we'll go to short circuit focus, and you can see that the ribbon changes when we get into short circuit focus. Now I'm going to hit this fault all the buses. This is like a batch fault. When I select that, all the different buses are faulted, and you can see here's 26 kiloamps, 20 kiloamps from the transformer, and about 1900 amps from the motor control centers. Now we can look at different options such as interrupting and 30 cycle fault currents. We can look at arc flash. We can hit equipment duty, except that we size this with smart design so everything's sized correctly, so we won't see a whole lot of information there. So the next thing we want to take a look at is protective device coordination. So I'm going to click on this little focus button, and what I'm going to do then is just highlight this section. I'm going to hit plot TCC, and over on the left hand side is the one line that we're analyzing. If I hit the faulted bus currents, you can see all the short circuit currents on from the MCCs and everything. Now this is a system-wide total current. I'm going to get rid of the title block so you can see this a little bit bigger. Now what I'm going to do is press Smart PDC. This is the world's first automated protective device coordination program. Now you can see that this system is not selectively coordinated. When I click on this button, it's going to selectively coordinate everything, and I'll just drag these tooltips over here, and we can actually zoom in and see the coordination. So you can see everything's correct. We can actually click on different devices, right mouse click and say insert difference calculators, and you can actually see the protective device coordination, and we can slide these up and down and or across and get all the information that we need. Now another thing we like to look at when we're in protective device coordination is what's actually happening to the arc flash hazard. Now you can see when I go and press this little arc flash button what the arc flash based on our current settings are going to be. So you can see down at the motor control center we've got 8.4 calories, number 3 PPE. Up on the main breaker, incoming breaker, is 79 calories, and then that breaker then is protecting the bus 4 switchgear lineup at 15.9 calories. So you can see with just a couple mouse clicks we can analyze just about anything there is to see. Now we can make adjustments, and that will change the arc flash hazard values. Let's go back to short circuit focus. I'm going to click out of here. We're not going to save this information. And if we go and press our fault all the buses based on short circuit focus, you can see here are our values for the different parts of the system. And if we go to our arc flash hazard report, we can say, okay, let's go get a report. And you can see all of our different values. What's at extreme danger. The pink shows that the 85% rule was used, and then we can just click on a particular item and we can view our arc flash hazard label. So you can see this gives you a really quick and easy way to create your one line, get all your arc flash hazard results, your protective device coordination, and your short circuit results. There's many other features in Easy Power, including dynamic stability, transient motor starting, harmonics, power flow, elevation schedules, multiple drawings, but this gives you a quick overview. Thanks for taking the time and looking at Easy Power.